Very good morning to all of you. Today we will discuss engineering thermodynamics. The subject is engineering thermodynamics. This is problem question number 42. Last class we have completed 41 number of questions. Today this is question number 42. The question is 10 kg of air is polytropically compressed from 100 kilopascal to 400 kilopascal. Clear? P1 100 kilopascal, P2 400 kilopascal. According to the law, Pv to the power 1.3 constant, N 1.3. The initial temperature is 27 degree centigrade. Find what done, change in internal energy, heat transfer, and change in enthalpy. Right? This is asking questions, 4 number of questions is asking. This is our given data. So first draw the figure. This is a compression process. Polytropically compressed. Air is polytropically compressed. Right? So this is a compression process. This is volume V. This is pressure P. This is compression process 1, 2. 1, 2. Right? So this is V1, this is V2, this is P1, this is P2. The law is Pv to n constant. Pv to the power of n is equal to constant. Clear? Now, given data, what is mass is equal to? Mass m is equal to 10 kg. 10 kg of air. This is air. Air. Clear? What is mass? 10 kg. Is compressed polytropically according to the law Pv to 1.3 constant. Pv to the power of 1.3 constant. This implies what is n is equal to? Pv to n constant. This implies what is n is equal to? 1.3. Clear? From initial condition 100 kilopascal to 400 kilopascal, 1 kilopascal is equal to 1 kilonewton per meter square. Right? The question is 100 kilopascal to 400 kilopascal. What is P1 is equal to? 100 kilopascal. What is P2 is equal to? 400 kilopascal. Means kilonewton per meter square. At temperature 27 degree centigrade, P1 27 plus 273 200 Kelvin. Right? Find work done, change internal energy, heat transfer, change in enthalpy. These 4 questions are required to find out. This is given data, this is given data. First find out what is T2. Clear? Now T2 is equal to final temperature. For T2 by T1 is equal to P2 by P1 to the power of n minus 1 by n. Clear? So what is T2 is equal to? P1 into P2 by P1 to the power of n minus 1. So T2 is equal to T1 300, T2 P1 400 by 100 to the power of 1.3 minus 1 1.3. To find T2. Clear? Use calculator and make calculation for T2. Now P1 given, P2 given, right? P1 T2 given. For air, what is Cp is equal to 1.005 kilojoule per kg Kelvin. Clear? What is Cp is equal to 0.718 kilojoule per kg Kelvin. So gamma is equal to Cp is equal to 1.4. What is R? Cp minus Cb 0.287 kilojoule per kg Kelvin. Now what done? Number one, what done? What is what done is equal to V1 minus V2 by n minus 1. Clear? What is what done is equal to MRT1 minus MRT2 by n minus 1. What is M? 10 kg. N 1.3. R 0.287. T and T2 are given answer. So what done is equal to MR common T1 minus T2 and minus 1. This is kilojoule. Why this is kilojoule? Because M kg, R kilojoule per kg Kelvin, T1 minus T2 Kelvin by n minus 1 in less. This cancels out. This cancel out. This answer is kilojoule. Right? So find the answer. This answer will be negative because this compression work. So this is negative answer. Number two. Number two, change in internal energy. Change in internal energy. What del U? M Cb T21. Put all values. M 10 kg, C 0.718, T21 all values put. Find the answer in kilojoule. M in kg, Cb kilojoule per kg Kelvin, T21 Kelvin. So this cancels kg Kelvin. The answer is in kilojoule. Right. Next, heat transfer. Heat transfer. Q is equal to W per del U. Clear? Work done cross change in internal energy. W is kilojoule, del is kilojoule. So the answer is in kilojoule. The answer is in kilojoule. Or you can also find out the heat transfer by putting original formula. So Q is equal to gamma minus n by gamma minus 1 into watt done. Clear? Gamma minus n by gamma minus 1, no unit, only watt done is kilojoule. So the answer is also in kilojoule. Right? Put the values, find the answer of heat transfer. Then change in enthalpy. Change in enthalpy. Deltas M Cp T minus T1. Clear? What is M? 10 kg. Cp 1.005 kilojoule per kg Kelvin. No, this is kg, 10 kg. This is 1.005 kilojoule per kg Kelvin. This is T21 Kelvin. So the answer is also in kilojoule. Right? So find del U, del H in kilojoule. These are 4 answers, all are kilojoule. So use calculator and find the answer. Right? Next question 43. The question is 43. This is question number 43. The question is, so that the heat added to a closed system at a constant pressure process is equal to change of enthalpy. Clear? The heat added to a closed system at a constant pressure process is equal to the change in enthalpy. First, what is enthalpy? Clear? According to law of conservation of energy, clear? What dq is equal to? dq is equal to du plus dw. Right? So dq is equal to du plus dv. Equation 1. Equation 1. Also, enthalpy. What is H is equal to? U plus PV. Differentiating both sides. Differentiating both sides. What dH is equal to? du plus d into PV. Clear? This implies what dH is equal to? dH is equal to du plus pdv plus vdp d into mn dm plus dn m dn plus n dm. So dpdv pb, difference of pv is equal to pdv plus vdp. Clear? This is 0 because for constant pressure process, change of pressure 0, right? But dh is equal to du plus pdv. This is equation 2. Equation 2. This is equation 1. So both right side equal, so left side also equal. So from equation 1 and 2, or 1 is equal to, what dq is equal to ds. That is what ds. That is the heat transfer is equal to change in enthalpy for which process? For constant pressure process. Clear? Hence, for constant pressure process, heat transfer is equal to change of enthalpy. Change of enthalpy. Clear? Next question 43, 44. Question number 44. Short question, 6-mark question. The question is, so that the stored energy of an isolated system remains constant. Isolated system. In the previous classes, we have discussed about isolated system. This is isolated system. Clear? The surrounding, this is surrounding, this is system. This is surrounding. The question is, prove that the stored energy of an isolated system is constant. That means the energy, initial energy is equal to final energy. Stored energy means initially, finally, both are equal. Right? This isolated system, we have already discussed what is isolated system. There is no heat interaction, also no work interaction between the system and surrounding. No heat transfer takes place from inside to outside or from outside to inside. That is isolated system, no heat transfer, and also no work transfer, and also no work transfer takes place. Takes place. Clear? That is dq0 dw is equal to 0. Only energy remains constant. According to according to law of conservation of energy, conservation of energy, or dq is equal to dw plus del u. Clear? But what del u? U2 means u1. This implies dq is equal to dw plus u2 minus u1. What is u2? Final internal energy. What is u1? Initial internal energy. But this is 0. This is for isolated system. dq 0, dw 0. So u2 minus u1 is 0. This implies u1 is equal to u2. u1 is equal to u2. This implies initially internal energy, initial internal energy is equal to final internal energy. Final energy. Clear? That is the stored energy. Stored energy of an isolated system remains constant. Remains constant. Next question 45. We will discuss some law of thermodynamics. We have also already discussed these laws, but again I repeat this. Clear? Laws of thermodynamics. I have already discussed you all gas laws and law of conservation energy. Now there are three laws of thermodynamics. One, zeroth law of thermodynamics. Zeroth law of thermodynamics. Zeroth law of thermodynamics. Number two, first law of thermodynamics. Number three, second law of thermodynamics. Clear? Now I will discuss these two laws. What zeroth law, what is first law? The second law I will discuss later. Right? Now I will discuss only two laws. The problem of these laws already done. Theory also I will discuss it. But today I will do the application of first law of thermodynamics. So before doing application of first law of thermodynamics, let us study for energy equation. I will again repeat what is first law and what is zeroth law of thermodynamics. Now first I will discuss what is zeroth law of thermodynamics. Clear? Zeroth law. Suppose there are three bodies A, B, C. Right? Suppose body A is equal temperature with the B. Thermal equilibrium means equal temperature. And also body B A is equal temperature with the body C. Then both B and C are thermal equilibrium with each other. That is, B and C are equal temperature with each other. This is zeroth law of thermodynamics. Clear? The law states that if two bodies are in thermal equilibrium with each other. Clear? Also, separately with a third one, with a third one, then all of them are in thermal equilibrium with each other. Thermal equilibrium with each other. Clear? This is zeroth law of thermodynamics. What zeroth law? The law states that if two bodies are in thermal equilibrium with each other, suppose the body A and B are equal temperature with each other. Also separately, A and C are equal temperature with each other. Then both B and C are temperature equal with each other. Finally, A, B, C all are thermal equilibrium with each other. Right? The law states that if two bodies are in thermal equilibrium with each other, also separately with the third one, then all of them are thermal equilibrium with each other. That is, if a body A is equal in temperature with the body B, Also, the body A is equivalent temperature with body C. Body C. Then both B and C are equal in temperature, equal in temperature with each other. There. Finally, A, B, C. The body A, B, and C, all of them are equal in temperature with each other. Clear? This is zeroth law of thermodynamics. Next, first law of thermodynamics. First law of thermodynamics. Number 2. The law states that the law states that heat and work heat and work are mutually compatible, are mutually compatible. Clear? Mutually compatible. Law states that heat and work are mutually compatible. When system executes a cyclic process, when system executes a cyclic process, the net heat transfer, the net heat transfer is equal to the net work transfer. The net work transfer. There. That is cycle integral of dq is equal to cycle integral of d double. Clear? dq small, cycle integration, cycle integration over a cycle. Clear? The symbol cycle integral stands for cyclic integral. That means integration over a cycle. Over a cycle. And dq and dwr and dq and dwr infinitely small amount of infinitely small amount of heat transfer and work transfer and work transfer. Clear? This is first law of thermodynamics. This means total heat transfer is equal to total work transfer. For cyclic process, the change in internal energy is 0. That is W is equal to 0. du is equal to 0. Clear? So this means this implies summation of dq is equal to summation of dw. Right? Total heat transfer is equal to total work transfer. For cyclic process, del is 0. When system completes a cycle, its change in internal energy 0. So what is the law of conservation of energy? dq is equal to dw plus du. If du is 0, dq is equal to dw. Topic. This is a new topic. This is applications of first law of thermodynamics to steady flow process. We will derive steady flow energy equation. Clear? We will derive steady flow energy equation. SFE. The application of first law to steady flow process. I will clearly discuss about this process and derive the equation for steady flow energy. That means SFE, steady flow energy equation. Clear? This is system, this is boundary. Inlet, outlet. This is day 2 level. From day 2 level, the inlet is at height of Z1. The outlet is at height of Z2. Right? Z1, Z2. This inlet 1, outlet 2. Heat supply to inlet, work done at outlet. The total heat supplied is at inlet and total work done is at outlet. Right? Now, what are steady flow energy equation? That means there are two essential conditions for this equation. Now, one, the total mass flow rate at inlet is equal to the total mass flow rate at outlet. Right? The total mass flow at inlet equal to total mass flow at outlet. The total energy at inlet is equal to the total energy at outlet. That is M1 is equal to M2, E1 is equal to E2. Clear? M1 is equal to M2, E1 is equal to E2. The two conditions satisfies this equation. One condition, total mass flow rate entering the system is equal to total mass flow rate out of the system. Total energy at the inlet is equal to total energy at outlet. Right? The two essential conditions, the two essential conditions for steady flow energy is are number one, the mass flow rate, the mass flow rate entering the system, entering the system is equal to mass flow rate leaving the system. There, m dot, m1 dot is equal to m2 dot. What dot? Dot means per second, dm by dt. M dot. What unit? kg per second. Clear? The total mass fluid flow rate. The total flow rate means mass of fluid flowing per second at entry is equal to the mass of fluid flowing per second exists. That is m1 is m2 is m. Number two, the total energy entering the system is equal to the total energy leaving the system, leaving the system. That is Q1 is equal to Q. Clear? This equation 2, this equation 1. Right? Next, consider a steady flow system S1 figure. S1 figure. Let P1 is equal to pressure of fluid at section 1. Clear? V1 is equal to volume of fluid at section 1. Total volume of fluid. BS1 specific volume at section 1. Z1 datum height at section 1. Clear? U1 U1 is equal to internal energy at section 1. Clear? H1 enthalpy at section 1. Velocity B1 bar, velocity of fluid at section 1. Clear? Similarly, P2, V2, BS2, Q2, H2, Z2, B2 bar. Clear? Pressure, volume, Sashi volume, internal energy, enthalpy, determinate, and velocity at section 2 is equal to corresponding values is equal to corresponding values at section 2, right? Q is equal to heat transferred at inlet or at section 1 to the fluid. W is equal to water net outlet or by the fluid. Clear? Now, what is H1? U1 plus U1 V1. What is H2? U2 plus U2 B2. Clear? What is flow energy? P1 V1 flow energy at inlet. P1 V1 flow energy at outlet. At a outlet U2 B2. Clear? Now, total energy at inlet. Total energy at inlet. E1 is equal to internal energy plus flow energy plus potential energy plus kind energy plus heat supplied, right? What is E1 is equal to heat energy, E1 flow energy, Q1 V1 plus potential energy, mg Z1, clear, plus kind energy of mv1 square plus heat supplied Q, right? What is this? H1. What is E1 is equal to H1 plus mg Z1 plus half m v1 square bar by v1 square plus q is equation 1, clear? Similarly, this equation 1, total energy at outlet, total energy at outlet E2 is equal to H2 plus mg Z2 plus half m v2 square plus w, clear? So what is E2 is equal to, what is H2? This is U2 plus E2 V2, clear? Plus this internal energy, flow energy, potential energy, kinetic energy plus work done. So what is this? H2. What is E2 is equal to H2 plus mg Z2 plus half m v2 square plus w 2, clear? According to steady flow energy equation 2, according to condition 2, what is condition 2? E1 is equal to E2, equation 1 is equal to equation 2, right? So what is equation 1? H1 plus mg Z1 plus half m v1 square plus q is equal to H2 plus mg Z2 plus half m v2 square plus w, right? This is known as steady flow energy equation. This is known as steady flow energy equation. That is SFE. Clear? SFE. So what is this? E1. This is, what is this? K1. This is E2. This is K2. Clear? So H1 plus P1 plus K1 plus Q is equal to H2 plus P2 plus K2 plus W. Clear? This is known as steady flow energy equation, or this can also be written as H2 minus H1 is equal to, or this can also be written as Q minus W. Q minus W is equal to H2 minus H1 plus P2 minus P1 plus K2 minus K1. Clear? This is known as steady flow energy equation. This equation is known as steady flow energy equation. Clear? So the mass M, note, the mass M or mass flow rate M dot, can you find out? Can be found out from equation of continuity. Equation of continuity. That is, what is equation of continuity? That is, M dot is equal to M dot is equal to A1 B1 bar by BS1, A2 B2 bar by BS2. This is known as equation of continuity. Equation of continuity. Clear? In this equation, M dot is equal to area meter square. This is velocity meter per second. Clear? By surface volume meter cube per kg. Right? The answer is meter per second by meter per kg. This is meter per second into kg per meter cube. Clear? Cancels out. This will kg per second. So this is mass flow rate. What is this? M dot. So you know M dot is equal to This is mass of fluid flowing per second. So what is its unit is kg per second, right? A is in area. Here, what is A is equal to? Area in meter square. What B bar is equal to? Velocity in meter per second. What Bs1 is equal to? Sissy balloon. What unit? Mass per kg. Right? Put all the units, you get this answer kg per second. This equation of continuity. Equation of now this theory completes for steady flow energy equation. Next class, I will do some problems regarding this equation. Clear? Thank you. Please make like, share, subscribe, and watch the full video. Thank you.